Today we're going to talk about factoring some more. I'm going to give you another technique for factoring polynomials. So let's first talk about if we were just going to factor the number 330, just a simple integer. We had talked about all the clues that we might have when we're trying to factor. First clue might be, well, this number ends in 0, so that means it's divisible by 10, so I could write out the first two factors as 33 and 10. 33 times 10 is 330. Okay, then you may remember the technique that if you add up the digits and you get a number that's divisible by 3, like the number 6, that means that 33 has to be a multiple of 3. So I could further write out factors. I've got 3 times, 11, and then 10, of course, you guys know is 5. 5 and 10, those are the factors. So that's how we would use clues to break down an integer like that. Now let's take a look at if we have a polynomial and we're looking for some clues. Move this over. There are a few things we could do. We could factor or use the quadratic formula. We could use a calculator to find the zeros like we did on our most recent quiz. But we could also use what's called the rational root theorem. This is something that you learned last year. And it's used to find all the possible rational roots, or meaning fractions, of a polynomial. And in this case, the possible rational roots are x equals plus or minus p over q. The factors of p are the factors of the constant term at the end of the polynomial, and q are the factors of the leading coefficient. So go ahead and write that down. So let's just review again what rational numbers are. So here we have a big group of numbers, the complex roots, okay, which includes imaginary numbers and real numbers. And within that, we have real numbers, okay, and within that, we have rational numbers. So rational numbers are any number that can be made into a fraction. Okay, again, so rational numbers are numbers that can be made into a fraction, but specifically you got to have an integer in the numerator and an integer in the denominator. No square roots, nothing funky like that. And you can't have 0 in the denominator. Okay, then it wouldn't be a rational number. So a rational number is a very specific type of number. I'm going to give you some examples here. Let's see. So on the left side, you can see some rational numbers like -1/2. 0.7 can be made into 7/10. 1 over 0.63 can be made into 100 over 63. So all of these are considered to be rational numbers. 0 is a rational number. The key is I can't have 0 in the denominator. Not rational numbers would be numbers like e or 1 over 0, radical 2, pi, 4i, those are all not rational numbers. So again, if I look at all of the complex roots, or the complex numbers, inside of that I'd have real numbers, and with the imaginary numbers there on the outside, between the red and the black, and rational numbers are a very specific type of real number. Okay, so let's take a look now at writing linear factorization. Hang on one second here. Okay. So what I would do if I wanted to write the linear factorization here of this giant polynomial, I would first write out all the rational roots, and okay, so the constant term is 8, and its factors are in yellow here in this fraction I'm making for possible rational roots. The factors of 8 are plus or minus 8, 4, 2, and 1. Then I look at the leading coefficient, which is 2, and I write out its factors, which are just 2 and 1. Next, I just simplify that giant fraction, and I write out what all the possible roots are. So I've got plus or minus 8, 4, 2, 1, and 1/2. So you may remember from last year that this is a little bit of a guessing game. I've got, let's see, it looks like I've got 10 different roots to try. We're going to try using the number 4. You could really start anywhere. I'll just give you a little hint, spoiler, that 4 works. So we're going to go with that one first. Okay, so we're going to try to see if the factor x minus 4 is a factor. And so I'm going to use the root 4, putting a positive 4 here. And then I'm going to write all the coefficients. Up at the top, I'm using synthetic division. So in using synthetic division, ... you guys know how to do that, I end up with a remainder of 0. So that tells me that 4 is a root. That means x minus 4 is a factor. I have found the first factor, which is good news. Okay, so 4 is a root, so x minus 4 is a factor, and I can write out my new factorization. And I'm using this 2, 1, negative 4, negative 2. That shows up in the new trinomial that's multiplied here by the x minus 4. So I've still got quite a bit of factoring to do, so I'm going to try using the rational root theorem again, recognizing that p and q in this case now are both 2. Okay, so now I'm down to a trinomial. This gets a little bit easier. My p and q are smaller. I write out the factors, and I figure out what the possible roots are going to be. Let me move this over a bit so you can see all of it. So my possible roots then are going to be plus or minus negative 2, 1, or 1/2. Okay, so I figured out what the possible roots are. Now I'm going to try a number. I'm going to try using a root of 1/2. I do synthetic division again. This time I have a remainder, and so I know that 1/2 is not one of the roots. But if I try the root negative 1/2, I can see that negative 1/2 works out nicely with a remainder of 0 when I use synthetic division. So since negative 1/2 is a root, that means that x plus 1/2 is a factor. Okay, so that trinomial we were left with, we narrowed it down to some rational factors. We tried 1/2, it didn't work. We tried negative 1/2, and it did work. So now we knew from before that x minus 4 was a factor. Now we know that x plus 1/2 is a factor, and we know that we've got 2x squared minus 4 left over. You can see on the right there with our synthetic division, we have 2x squared minus 4 left over. Okay, so now we're down to a quadratic, and we have lots more options for figuring out what the factors are. Okay, so we've written out the factors. On the second line, you can see where I just factored out the 2. From the 2x squared minus 4, I moved the 2 to the front. You could write it either way. Both of those are properly factored. Okay, so what I'm going to do now is just factor that yellow highlighted portion, the x squared minus 2, quadratic binomial. So you can see whichever way it was factored or written, whether it was x squared minus 2 or 2x squared minus 4, it doesn't matter. Either way, you're going to come up with 2 roots, plus or minus square root of 2. Okay, so from there, we can write out the full linear factorization. Since I've got the 2 roots of plus or minus root 2, I wrote those out at the end. It's x plus root 2, x minus root 2. You can see that I've got the x minus 4. I used 2x plus 1. And the reason I did that, instead of using x plus 1/2, because I want to make sure that I have the same leading coefficient in the end. If I just had x plus 1/2 there and I didn't put that 2 in there, then I'm not going to have the same polynomial that I did in the beginning. I won't have that same stretch. You can see in blue I've got the original polynomial, and again we've got a coefficient of 2 in the beginning, and so you have to make sure that that gets maintained. Okay, now let's use the rational root theorem to try to solve an equation. So the first thing I'm going to do is move the couple of terms from the right side to the left side and set them equal to 0. Next, I'm writing out the possible rational roots. So p is the constant term 2. I'm writing out its factors, plus or minus 2 and 1. Q is the number 3, or its factors are going to be 3, plus or minus 3 or 1. So I write out I've got 8 different factors there in green. Okay, so to save time, I'm going to go ahead and tell you that one of the numbers, one of the roots is 1. You would have to try all 8 potentially, but 1's always a nice one to try first because it's easy. So if we look and see if 1 is a root. I use synthetic division, and look at that. We have no remainder, so 1 is a root. And so that means I can write out a new factorization. So just a reminder, the 3, 7, and 2 get transferred over to the new quadratic, right? 3x squared plus 7x plus 2. All of that times x minus 1 would have to equal 0. So you can see here I factored my 3x squared plus 7x plus 2. And then from there, I set either one of those binomials equal to 0, and I came up with 2 other roots. So that means that the solutions to my original equation are 1, -1/3, and -2. Okay, so that concludes this short but sweet lesson, and from here on out I would like you to try some problems in the book. I think it's maybe 6 problems. And yeah, please do these. Make sure that you check answers, and we will talk more later.